The first of the practice problems is to convert a binary number into its equivalent decimal. As you'll notice, there's a binary point that separates the integral part from the fractional part, and the integral part, this would correspond to 1 times 2 to the 0. This would be 1 times 2 squared. There's nothing in here. And this would be 1 times 2 cubed. In other words, this is 8, this is 4, and this would be 1, and this is 0 in here. So the integral part would be 13 in decimal. Meanwhile, to the right of the binary point, this would be nothing times 2 to the minus 1. This would be 1 times 2 to the minus 2. This would be 1 times 2 to the minus 3. So this part would correspond to a quarter, or 0.25. This would be 0.125. So if we add these together, we get 0.375. Join up with this, we get 13.375 base 10, or in decimal. Fairly easy conversion problem. Second problem, number 2, we're asked to take the product of two complex numbers, 4 plus j5 times 2 plus j3. Several ways of doing this. One way, of course, is to convert each of these into polar form and then multiply the magnitudes together and add the angles. Or we can do a straight rectangular multiplication, doing something like this. Write 4 plus j5 up here. Underneath, write 2 plus j3. 2 4s are 8. 2 times j5 gives us j10. This gives us j12. And this last part here gives us plus j squared times 15. J squared times 15. So when we add these together, this of course is 8. This is j22. Now j squared is the same as minus 1. So this becomes minus 15. So when we put it all together, we have the minus 15 and the 8 gives us minus 7 plus j22. So we've done this working strictly with rectangular coordinates, even though, as we said a little bit earlier, it could have been also done using polar form. Let's go on now to problem number 3. Problem number 3, we have 4 plus j5, a complex number, which we would like to multiply it by its conjugate, which is a star. Call this a. Then a star would simply be 4 minus j5. We'd like to take these two and multiply them together. Well, it says to do this using, first of all, polar coordinates. Well, if I convert this into polar form, where the two sides of a right-angled triangle are 4 and 5 respectively, I get a magnitude that's equal to, in polar form, the first part would give us the square root of 41. 16 plus 25 is 41, and would have an angle that's given by the arctangent, or the angle whose tangent is 5 over 4. 5 is the vertical side, 4 is the horizontal side. Now A conjugate would be almost the same as A. It has the same magnitude, but the angle would be minus the arctangent of 5 over 4. Well, we never have to look those angles up, because the way it turns out, if we now multiply these together, it's the same as multiplying the two amplitudes, which would give us 41, and the angle would be 0 degrees, because this angle and this angle are complementary, and they take each other out and give you 0 degrees. So you get 41 at 0 degrees.